Hello everyone, this is Dr. Shochinandan Datta, and in this video lecture I'll talk about the analysis of variance or Ancova. So first Ancova, so here C is added, so it's a similar thing of ANOVA. So here it's additionally we just add a covariance or covariate. So ANOVA, whenever added with covariance, it is called Ancova. So it's a like ANOVA. Ancova has a single continuous response variable. So it's the same like ANOVA, but it has a single continuous variable. And but unlike ANOVA, it's not like ANOVA because it has a both factor and a continuous independent variable. So here in case of ANOVA, we in both a continuous response variable are there, and in case of Ancova, that is not present in ANOVA, that is a with a factor and a continuous independent variable, both are present. Okay, and the continuous independent variable used in Ancova, that is called a covariate. So what is Ancova? So Ancova is a mixed of between ANOVA and the regression. So it's a mix between ANOVA and the regression. So it's a similar factorial ANOVA, and it can tells you the additional information. Similar, you can same as the ANOVA, but additional information that can it still that can get the considering our independent variable, that is a factor, means considering our independent variable, that is a factor at a time without the influence the other, other it can be changed, but the cofactor you can identify it, and it can use as an extension of multiple regression. So it is an extension of multiple regression, and to compare the multiple regression line, so here we can check the how to check a multiple regression line. We can check the multiple regression line 1 2 3 multiple regression line we compare, and another way an extension of ANOVA also. It is also extension of ANOVA. And in case of Ancova, it is basically what are the purpose of ANOVA? It basically experimental design. In case of experimental design, to control of a factor which cannot be randomized but which can be measured on an interval scale. So basically in case of you are doing an experiment, so in case of experiment you make a control and you have different factors, so that control can act as a factor here. So control for a factor which cannot be randomly, it cannot be randomized, but which can be measured on an interval scale, but it can be measured. What are the cofactors, or what are the factors that impacting your result? And in observational design, to remove the effect of a variable which modify the relationship of the categorical independent and interval dependent. So basically you make a experimental design, observational design, there will be the effect of variable which modify the relationship of the categorical variable and an interval of dependence. So that is we have to find a category variable independent and interval dependent. In general, the independent and dependent both are not category. So here the independent factors are the categorical variable. In regression model, it to fit a regression and where both the categorical and interval are independent. The third purpose is basically replaced by the logistic regression and other methods. I can see one of the more example that if the treatment of a high blood pressure, okay, high BP or hypertension, okay, so there are three different three different drugs, drug 1 2 3, and three different drugs are working on the hypertension, but if it is its outcome will be much more positive, you are getting the much more positive result from this after this treatment if a cofactor, that is is include, that is can be a diet. Okay, if you control your diet along with the medicine, then you improve a lot. Even you can also add a one more cofactor, that is you are adding a diet with treatment with this medicine along with the exercise. if you do exercise, that exercise and this diet, these are the cofactor that will be improved along with your drug. Okay, so and like one more example I give you in our agricultural field or fisheries field, like one here. And one more example that the fisheries, so you have three pond with three different treatment. So in different treatment in three pond you got different production. So that along with the treatment there is a cofactor that could be a temperature, that could be any environmental factors that affecting on that particular pond that have the highest production. So that is a covariance or cofactor. That these are the example of the analysis of covariance. So steps are first you have to run a regression. So regression between independent and dependent variable, and after getting the regression you have to extract the residuals, means that the errors, so slope, intercept and residuals. So in this residual you have to run the ANOVA. So run an ANOVA on the residuals. So first regression, then take the residuals, then run a ANOVA. So Ancova is it's a one thing is the independent factor, second thing is the dependent factor, and a covariate. So independent factor or predictive variable, that is a y. We are giving y is predictable variable, and it's a categorical variable. And like example, level of anxiety. So level of anxiety is depend upon the test course. Okay, so your anxiety is increase to seeing your course, what is your result, seeing your result in exam. So it's a dependent variable. So your your test course or your result is depend, it's a dependent variable. And this your level of anxiety is depend upon the course, your result. So if your result is good, your anxiety is low. If your result is bad, your anxiety will be high. And there is a cofactor, your score or your result will be good, then your anxiety will be low, and this result will be good, that is depend upon the that have a cofactor, that is the independent cofactor or predictable variable continuous, that with the number of hour of study, how many hours you are studying every day. Okay, that gives you that result, and that is independent on the level of anxiety. And if you delete this covariate, then it is a regression. Okay, now it is an GLM or a general linear model. We do the LM function in R for both all the three things. So consider having one one dependent variable, and it's a continuous data, and depending on the type of independent variable you would R. So there is one is the ANOVA, that is category variable and factor independent variable, and X continuous is varies. X bar is the dummy varies 0 to 1 level of the factors, and continuous independent variable, that is a linear regression. So in Ancova it's a combination of ANOVA and the regression, and basically it's a linear regression. Okay, so y is equal to here beta 0 plus beta 1 x1 beta 2 x2 x bar 2. Okay, and in linear regression it's the y is equal to beta 0 plus beta 1 x1 beta 2 x2. What Ancova is the combination between these things. Y is equal to beta 0 plus beta 1 x1 plus beta 1 x bar 1 beta 2 x2 plus beta 2 x bar 2. So these are a Ancova. So comparing the regression line. Okay, so after getting the regression, you do run an ANOVA to get the Ancova. Okay, that is a very simple thing. Okay, so let's check. In first case there is the slope and the intercept. Here you can check the your slope and intercept are is the slope and intercept are is the same. So what is the slope, what is the intercept, are the same. So there is no intercept and no slope in this line. So that is basically r square is equal to 1. It's a well, I mean 100% fits. Okay. Here your intercept is different. Here intercept 0.9, here intercept 0. So intercept are different, but slope is the same because the angle or the slope of the line 1 and line 2 is the same. Okay. In a third one, here you can check the intercept are safe, intercept are same, but your slope are different. So here is the slope and this one slope, this is the slope are different. And in the fourth here intercept is different and slope is also different. Okay, so this is a Ancova, and so different slope and different intercept. Okay, and here a different slope plus different intercept. Okay, now goal of the Ancova. Ancova basically analysis of covariance. So analysis of covariance. So Ancova is a factor that may affect the regression line and covariate. So what is the factor that affect your regression line varies? Okay, your regression line is varies because which factor? So that is Ancova. And type of data means one continuous dependent varies, at least one continuous independent variable, and at least one categorical variable. So for run an Ancova model, you always require a one continuous dependent variable, one independent variable, and one cofactor. Okay, purpose to test a difference in the regression line. So what is the difference? So this regression line, what are the difference between this regression line and between the categories? Okay, so null hypothesis is the this category membership does not affect the relationship between the variables. So this category relationship, it's not affect with the between the variable. So you have three variables, these are not effect same. Okay, but in alternative hypothesis, yes, your three factors are totally different. Okay, so here this is all about the goal of the Ancova. Now Ancova assumption. So variable y and x, a linear relationship and approximately equal variance. So x and y, it's equal in variance and it's a linear relationship. Okay, and points are independent on each other, and points are independent to each other. So residual and uncorrelated on times reach. So residual are not, they don't have any correlation in times. Okay, in respect to time, and variance of y is constant for all x. So what is in constant of all x means x1, 2, 3, 4, 5, 6, 7. What is the variance of y is always constant. Y is variable or variance is not changed. Okay, because that's the linear. And distribution of y is normal for all x, and y distribution of y is normal in terms of all x. So linear regression slope are equal, slopes are equal for all group, only equal for Ancova, and testing difference in intercept. And required the result of Ancova. So you require a scatter plot first, drawing a color plotted to see the best plot, one, and then the 2, and then the 3. So 3 or 4, whatever your variable. So first scatter plot with the best fit, and the test name, what is your test name, and cover state 1, 2, 3, model 1, model 2, model 3, and value of the F statistics. You have to calculate the F statistics, that's an important, and the degrees of freedom to qualify whether it is signify or not. On the other end, we can checking the p value for the significance of the test, or significance of the there is cofactor or covariance there or not. So what you write will differ depending on whether you test the slope or slope plus intercept. Okay, you are testing only the slope, or you are testing slope plus intercept. And you should describe how the slopes and intercept, or slope or intercept, differ between the groups. Now, multivariate analysis of variance. So, multivariate analysis of variance is similar to analysis of variance, and except the instant of one metric dependent variable, and we have two or more. Okay, so basically, Ancova have one covariates, but here instead of one metric dependent one dependent variable, here in terms of one, it's more than one, two or more than one dependent variables are there. That is basically Ancova. And in MANOVA, the null hypothesis is that the vector of means on multiply dependent variable are equal across the group, and multivariate analysis of variance is appropriate when there are two or more dependent variable and that are correlated. Okay. So thank you all for your understanding. Thank you.